Okay. Okay, see. So here we'll be discussing about frequency and angular frequency. See, in your grade 9 or earlier classes, you have studied grade 10, you have studied about the frequency. Frequency just means you have discussed frequency in terms of vibrations, right? Pritam, we have discussed frequency in terms of vibrations. We know how do we call a frequency? What is frequency? How can we define frequency? We define frequency as
Number of
the,
times which occurs.
yeah, the number of vibrations per second, right? But here we will see frequency in a broad way. We call frequency as the number of vibrations per second, but sometimes it may be vibrations, it may be some other repetitions. So frequency mainly means the repetitions. Okay, how many times it repeats per second, that we call as frequency, and it's measured in SI units called hertz. Okay, so it is a common thing that we need to know. So frequency we will be finding out for all the periodic motions. First of all the periodic motions, not only vibratory motions. Frequency we find out for all periodic motions. So what are periodic motions?
So like movement of pendulum.
Yeah, movement of pendulum that we call as the periodic motion. So a pendulum is a periodic motion. Pendulum shows a periodic motion. The motion of earth is also periodic. Motion of earth is periodic. Fan rotating with constant speed, is it periodic?
Yes, sir.
So it is also periodic. A fan rotating with constant speed is a periodic motion. So we will be discussing everywhere what is frequency. Is called as the number of vibrations per second. SI unit of the frequency being hertz. So if you know the time period, another thing that you should be knowing is the time period. Time period is the time taken to complete one vibration or one complete repetition. For example, if you see the time period of Earth's rotation. So what is the time period of Earth's rotation?
24
Yes,
hours. 24.
24 hours. And what is the time period for Earth's revolution?
365.
365 days. 365 days.
Yes, sir.
Yes. So time period is the time taken to complete one oscillation. Oscillation or revolution. Okay. And 1 over time period we call as the frequency. So frequency will be generally treated. Frequency is denoted by the symbol. Sometimes it's denoted by the symbol F, and sometimes the standard symbol for frequency is nu. So either we write nu as the symbol for frequency, and sometimes we can write F also. Okay. But if you see the standard is nu. This one is preferred. This it's measured in hertz. Sometimes it will also be measured as number of revolutions per second. Okay, so time period is also measured in second, the time taken to complete one oscillation, that we call as the time period. Now for different waves, we can talk of their time period, their frequency, wave velocities. Basically, as of now currently, we will be discussing mainly with the angular frequency. So if say, suppose I say that your fan completes, suppose your fan completes 600 revolutions per minute. Okay. So I talk that your fan completes 600 revolutions per minute. So what do I mean by this 600 revolutions per minute?
Like
What
time period.
quantity? Is it time period?
What quantity does
Yeah, what quantity is it representing? 600 revolutions per minute.
vector vector
Hmm?
vector?
Yeah, no, it's not vector. It represents the frequency.
Hmm.
600 revolutions per minute. It represents the frequency. See, number of circulations per second, number of revolutions per second. Okay. So the number of revolutions per second, the number of revolutions per minute, that will be the frequency. So here I'll treat this 600 revolutions per minute as frequency and convert it in terms of per second. I can also convert it to per second. So if I convert this 600 revolutions per minute into revolutions per second, so of course I will be getting 10 revolutions per second. So I can say the frequency would be 10 revolutions per second. For the fan, the frequency would be 10 revolutions per second. If we talk it in terms of oscillations, so at many times we'll be talking in terms of oscillations, where we mean that how many oscillations are being completed per second, that we call as the frequency. Now, we will be discussing here about the angular velocity and the angular movement, angular motion. So about the angular velocity, what we discuss about the angular velocity over here. See, if we have a quantity which is moving in a circle. So let's consider any object moving in a circle. Okay. Suppose this is the starting point, and from this starting point, an object starts moving in a circle. So I take this. Let this be the starting point, and from here the object moves in a circle. So how it moves? It goes round like this. So it can continue moving to be any number of times, right?
Hmm.
Which type of motion is performed by this compass?
Angular.
Angular motion. Now, just like the linear motion, angular motion also has its dynamics. Angular motion also has its description. So, suppose this was the starting point. Okay. So, I remove this. This was the starting point. And now, how do we talk of the angular motion? So, here, do we have any displacement? Can we talk of any displacement over here?
No, sir.
No.
What is the
So, see,
displacement?
we will talk here of the displacement, but that would be the angular displacement. So we will talk here of angular displacement. The angular displacement would be denoted by the symbol theta. Angular displacement simply means that how much angle has it traversed. Okay, so angular displacement would be measured in terms of theta. Okay, and this theta is also a vector quantity. So angular displacement will also be a vector quantity, but unlike the other vectors, unlike the linear displacement, whatever we have seen, if we talk of the angular displacement, so let us try to visualize the angular displacement. So from the center, this is the point up to which we are talking. This is the starting point. Yes. From the center, we have started up to the starting point. This is the starting. So let this point be P from where it has been started, and now it moves and comes over here, covering some angle theta. So this is your angle theta. Remember, P is the starting point, Q is the final point. So the angular displacement would be given by the symbol theta, right? So can you think of what direction will we give? Shall we give this curly direction to be the direction of theta? I say that it is a displacement, okay, and it is a vector quantity. So angular displacement is a vector quantity. It should have a direction also, right? So what should be the direction of the angular displacement? Okay. So see, here there are two types of angular displacements possible. From its initial position, there are two types of angular displacement. So the way I have taken it from P to Q. So this is the way I have taken from P to Q. Got it? So the angular displacement is not along PQ. I will talk of what is the direction of this angular displacement. The other direction which is possible is that it might have or it can go from P instead of going anti-clockwise, it could go in the clockwise direction also. Okay, it can travel the some angle theta in the downside also. Let this be the theta 1 and let this be theta 2. Okay. So the angular displacement which have been mentioned here, theta 1 and theta 2, they are displacements and their directions are taken up along the axis of their rotation. Okay. So the angular displacement is not along the circle, it is not in the plane of the circle. Angular displacement is taken along the axis of this circle. So that means the angular displacement will be taken in a direction perpendicular to the plane containing the circle and passing through the center. Understood this, everyone?
Sir, can you repeat it?
So this is a new thing you have got?
Sir, can you repeat that?
Yeah, again, sure. So what happens if from P, if an object moves in a circle, so there are two ways of its motion. There are two different ways in which it can move. It can move from P to Q in the anti-clockwise direction, and it can move from P to the other direction R, which will be a clockwise direction. Okay. So now the directions, how do we take these vectors? As we have represented vectors in a particular direction. So in which direction shall we represent the angular displacement theta? See, so for the positive angle and for these two angular displacements, we consider the angular displacement as a vector along the axis of this circular plane. Along the axis of this plane. So that means the angular displacement will be along a line perpendicular to the plane passing through its center. Understood this much?
How would you determine the direction?
How we determine that? Okay, so direction is clear. I'm just telling about the direction. Now, the one which is moving along the anti-clockwise direction, that is taken as positive. So this angular displacement will be taken as the positive displacement, and this angular displacement will be taken as the negative displacement. Okay, so this will be taken as the negative displacement. Let us see, try to recognize this on another plane. So see, the same thing I'm trying to represent you on a plane. So suppose you have this table. You have the table, and on this table you have an object moving in a circle. So here, okay. So you take an object over here. So this is an object moving in a circle. It has been shown something like this. It's a circle. Okay, it has been shown so that you are observing it to be on the plane. Now, if you mark the axis, so axis would be something like this. Axis would be a line passing through the center. Something like this, you will have the axis.
Yes.
Okay. So this is the axis. And now the axis can have two directions. From here, the upward direction of the axis. The upward direction of the axis will be the positive. And from here, we take this downward to be the negative. right? So if your object is revolving like this, suppose it's revolving from here. Okay. So these are the two positions which I have marked. Let this be point P and let this be point Q. So as I observe from the top, I observe it to be moving from P to Q. Okay. And this is an anti-clockwise direction,
Mm.
right?
Yes, sir.
So since it is an anti-clockwise direction, so therefore angular displacement, whatever angle it has covered, okay, so we will take the same angle, but its direction will be taken along the positive axis. Okay. Suppose it covers an angle of pi by 3 radian. This is your angular displacement. Your theta is equal to pi by 3 radian. So this pi by 3 radian will be taken along the positive axis.
That should be positive.
Yeah, we will say that the angular displacement is positive. Okay. If the object revolves in the clockwise direction, suppose from P, now it moves to the point R. Okay. So from P, it moves to R along this direction. So this direction is clearly the clockwise direction. We observe it to be moving in the direction of a clock. So this is a clockwise direction and it will be taken as a negative vector. The direct magnitude may be the same, but its direction will be taken along the negative direction. Okay. So got the value of the angular displacement. So
Yes,
just
sir.
like in the linear case, you have displacement which is measured in meter. The same way, if any object is moving in a circle, so it's a circular motion, or the how much it has traveled will be measured in terms of angles. Okay, and that would be necessarily in radian. If you talk of in terms of degrees, so suppose if an object moves through 2 rounds, if an object completes 2 rounds, so what would be the angular displacement? Yes. What would be the angular displacement of the particle?
Theta.
Theta. What value will be there for theta? If an object moves in the anti-clockwise direction, if an object moves like this in the anti-clockwise direction, okay, 2 rounds, if it completes 2 rounds, so how
2
much is
theta.
the angular displacement?
2 theta.
2 theta. Can I say that it will be 720 degree,
Uh,
right? It will travel an angle of 720 degree, right?
uh,
Yes. So in terms of angular, it has traveled an angular displacement of 720 degree. If it makes 3 rounds, so it will be 360 multiply 3. Okay. If you find out the same thing in terms of radian, so I told you in the earlier classes how to measure in radian. In radian, we know that pi radian is equal to 180 degree. This is what we learned, that pi radian will be equal to 180 degree. So if any object completes one revolution, it will have an angular displacement of 2 pi radian. Okay. So if an object completes 2 rounds, so it will have an angular displacement of 2 pi radian. If an object completes one circle, it will have 2 pi radian. If for 2 circles, it will have 720. That means 4 pi radian will be the angular displacement. Okay. So understood about the angular displacement?
mm,
Yes. Any doubt?
no.
No. Okay. So since we have understood about the angular displacement, we can get the next term, that is angular velocity. So we'll talk of angular velocity. What is the angular velocity? Angular velocity is the rate of traveling angular displacement, or the rate of traversing angular displacement. That means how fast an object is making angular displacement, that we call as the angular velocity. Okay. So the angular velocity, just like the linear velocity, it also has the symbol. The angular velocity is denoted by the symbol omega. It is denoted by the symbol omega, like this. So this is omega, which is the symbol for angular velocity. Right. So V was the symbol for, yes, what was the symbol V used for?
Velocity.
Linear velocity. We call it, earlier you were saying it velocity, and now we will call it as linear velocity, right? Because now we have another velocity. So this is your linear velocity. And now what we are talking here, this omega, is the angular velocity. So this is the angular velocity. How fast an object is revolving in a circle, we call that velocity to be the angular velocity. Okay. So angular velocity, like we can see the linear velocity v, it is given by displacement over time. This is how we know that linear velocity is given by displacement over time. And you also have the equations of motion for the linear motion, right? So here angular velocity will be given by omega, will be given by theta by t, where theta is the angular displacement and t is the time. Got it? The analogy is the same. Here you have displacement, here you have angular displacement, right? So angular velocity means how fast it is rotating. And so what should be the SI units of angular velocity?
Omega.
Yes, what should be the SI units? What should be the SI units of angular velocity? Okay, what is the SI unit of theta? What is the unit for theta? What unit do we use for theta? Radian. Theta we measure in radian and time we measure in second. So can we say that angular velocity will be measured in radian per second? Okay, so angular velocity will be measured in terms of radian per second. And if an object is moving in the anti-clockwise direction, so its angular velocity will be taken as positive. If an object is moving in the clockwise direction, so its angular velocity will be negative. Got it?
Yes.
So now we moving further. So do I need to repeat anything? Can we move further? Okay, okay. Let's try to do one question, then we will move further. Right? Just do one question. Uh, so here I give you a question and try to do that. See, uh, a fan completes. A fan revolves or rotates with 600 RPM. RPM means rotations per second or rotations per minute or revolutions per minute in anti-clockwise direction. Anti-clockwise direction. Find its angular velocity. So you have to find the angular velocity. Let us try to do this. So a fan rotates. It makes how many rotations are there per minute?
600.
600. So how many rotations will be there per second?
100. No,
3600.
no. 10, 10.
10. So it would be equal to 10 rotations per second. Okay. So we call it 10 rotations per second. Okay. So, and also I told you, you know that one rotation, what is the angle covered in one rotation? How much angle does it cover in one rotation?
Theta.
No, not theta. If any object completes one rotation, so what this
360.
angle is? 360. So in degree, this is 360, and in radian, this is equal to 2 pi radian. Okay. So one rotation would be equal to 2 pi radian. Got it?
Mm.
You are finding it just difficult for the first time. We will do a number of questions. Okay. Do not, we will not jump up. We'll do, we are just here to clear these basic concepts. Otherwise, see, you are not able to get this right now. So when you are in grade 11, when you start with grade 11 with the course, so over there, no one explains such small things. You are supposed to guess this on your own. Okay. So these are over there, these are tiny things which you should know. So this is why we are here, just to practice these things. So one rotation would be 2 pi radian, and therefore 10 rotations. So 10 rotations would be equal to 20 pi radian. Am I correct? Jaswant, are you getting? Jaswant?
Yes, yes, sir. Yes, I'm
Okay.
getting.
Dhananjay, what about you?
Yes, sir, I'm getting it.
Okay. So 10 rotations would be 20 pi radians, and these 20 pi radians or 10 rotations are completed per second. So you can write it 20 pi radians per second. So what would be the angular velocity? Can I say that the angular velocity v will be equal to 20 pi radian per second?
Mm.
Got it?
Yes.
Yes,
Okay.
sir.
Now, can you tell me what will be the angular displacement? Who can find the angular displacement? See, you have the angular velocity. Okay. You will find out, find the angular velocity, find the angular displacement, find the angular displacement in 20 seconds. Find the angular displacement in 20 seconds.
180.
What 180?
With the angular displacement.
So 180 units. What unit you will get? See, use the formula. See, speed equal distance upon time. That's the same thing. Velocity equal displacement over time. So you know that omega will be equal to theta by t. Okay. You are given t, which is 20 second. You know omega, which is 20 pi. You want to find out theta. So can you tell the answer now?
405 radian.
Yeah, very good. Correct. Dhanunjay, you are correct. So if you want to find out angular displacement, which is theta, so you will get here omega multiply t would be equal to theta. Omega is 20 pi and t is 20. So you get your answer 400 pi radian. So this would be 400 pi
Radian.
radian. Got it?
Hmm.
Okay. Now a shortcut for this previous one. For the previous question, whatever we did previously, there is a shortcut that I'm giving you. And the shortcut is that you can use the formula omega equals, so here you can use omega equals 2 pi f. If you know the frequency and you want to find out the angular velocity, you can use the formula omega equals to 2 pi f. Okay, so keep this formula, note down this formula.
Yeah.
Today you will be getting homework only with these topics: angular velocity, frequency, time period, only these things. Right? Okay, so will you do one more question? Will you do one more question now?
Yes.
Okay. Okay, let's do one more question. Yes. The wheel of a car rotates with 25 RPS. Okay. It rotates, sorry, 25, let's not let's say 2.5 RPS. Find its angular velocity. Find its angular velocity. The wheel of a car rotates with 2.5 rotations per second. Find its angular velocity. Also find its angular displacement in 4 seconds. Okay. So this question is your homework. You can do it. Okay, Dhanunjay has given one of the answers, and both the answers actually he has given. Okay. Okay, so bye both of you. Just Dhanunjay, you are correct. Okay.
Okay.
Okay, bye.
Okay, sir. Thank you, sir. Have a nice day.
Goodbye.